Hello friends, my name is Shubhadeep Das. I was teaching you chapter variation from the book Ganit Prakash of West Bengal Board of Secondary Education class 10, and we have solved till question number 6 in my previous videos. In this video I am going to start from question number 7 Roman 1. Look at question number 7 Roman 1. If a square plus b square is directly related to b, let us prove that a plus b will be directly related to a minus b. Okay, so this is the given relation and we have to prove this relation using this. So a square plus b square is directly related to ab, and show that a plus b is directly related to a minus b. A square plus b square is directly proportional to AB. And we can say a square plus b square, removing this various sign, we can bring an equal to and a constant, and after that into AB. So this relation can be written as this. So it is converted to an equation. Now let us do or let us bring AB to the left side. So it becomes a square plus b square by AB equal to k. We are multiplying AB with 2, so we must adjust it by writing a 2 in the denominator. So we can write this expression as this. So we can adjust this 2 in the numerator and the denominator. So it becomes a square plus b square equal to k by 2 equal to k by 2 into 2ab. Now if we bring 2ab to the left side, okay, it becomes a square plus b square by 2ab equal to k by 2. Now we can apply componendo dividendo. So applying componendo dividendo, we get numerator plus denominator by numerator minus denominator. So it will become a square plus b square plus 2ab by a square plus b square minus 2ab equal to k plus 2 by k minus 2. Now we can write the numerator as a plus b whole square by a minus b whole square equal to k plus 2 by k minus 2. Now applying square root on both sides, it becomes a plus b by a minus b equal to root over k plus 2 k minus 2. So this is a constant, as k is a constant. So this is a constant, k plus 2 by k minus 2. This is a constant. So we can write these as c. So root over k plus 2 by k minus 2 is c. So this is a new constant. So as we see that or we can write it like this: a plus b equal to c into a minus b. Or simply we can say a plus b is directly related to a minus b. So this is what we needed to show: a plus b is directly related to a minus b. So it is done. I hope you all understand this question well. This part is not needed. Okay, so this is our solution. I hope you all understand it. Let us now proceed to our next question, that is Roman 2 of 7. Roman 2 of question number 7 says, if x cube plus y cube is directly related to x cube minus y cube, let us prove that x plus y will be directly related to x minus y. So let us see. Roman 2, x cube plus y cube is directly related to x cube minus y cube. It is given. Show that x plus y will be directly related to x minus y. Now let us start from this relation, the given relation. Let us write it first: x cube plus y cube is directly related to x cube minus y cube. Or x cube x cube plus y cube equal to a constant into x cube minus y cube. Now if we take this quantity to the left side, it becomes x cube minus y cube equal to k. Now applying componendo dividendo, we get x cube plus y cube plus x cube minus y cube by x cube plus y cube minus x cube. So numerator minus denominator, so if we apply minus here, x cube becomes negative and y cube becomes positive. So I am changing their signs. So k plus 1 by k minus 1. Now from this step we can write, okay, we can just cancel y minus y cube and plus y cube, plus x cube and minus x cube. So it becomes 2x cube by 2y cube. It is k plus 1 k minus 1. Now we are applying cube root on both sides. So the left side becomes x by y and the right side becomes k plus 1 by k minus 1 to the power 1/3. So this is a constant, k plus 1 by k minus 1 to the power 1/3. This is a constant, this is 3. So this is a constant. We can write this as, say, c. So x by y is a constant. Now We can again apply componendo dividendo. Applying componendo dividendo, we get x plus y by x minus y equal to c plus 1 by c minus 1. So this becomes, if we take x minus y to this side, or x plus y equal to c plus 1 by c minus 1 into x minus y. So as we see that this is a constant and this is equal to, we can eliminate these things with a varies as sign. So x plus y varies as x minus y. So this is our required solution. We had to show this relation. If 15 farmers can cultivate 18 bighas of land in 5 days, let us determine by using theory of variation the number of days required by 10 farmers to cultivate 12 bighas of land. Okay, so let us first write the given information. Number of farmers number of bighas and number of days. So the first condition says 15 farmers can cultivate 18 bighas of land in 5 days. Now 10 farmers, 12 bighas, how many days? So this is our question. So first of all, we should establish the relations between these quantities. So number of farmers and number of bighas. Okay, number of farmers and number of bigha. Okay, number of farmers and number of days, let us say. Okay, number of farmers and number of days. Okay, number of farmers and number of days. If we increase the number of farmers, the number of days required to cultivate a certain number of bighas if we increase the number of farmers, number of days required will be decreased. So these two quantities are inversely related. So these two quantities are inversely related. Now let us say number of bighas and number of days. If we increase number of bighas, number of days will also be increased. So these two quantities are directly related. Okay, inverse relation and direct relation. So now we have established the relations. So we can write, let us say number of farmers are denoted by NF, F in suffix. Number of bighas is represented by NB, and number of days is represented by ND. Okay, now we can write NF is inversely related to number of days, or let us write it this way. Okay, number of days is inversely related to number of farmers. Okay, and number of days is directly related to number of bighas. So these are the relations. Now if we combine these two relations, we get number of days directly proportional. Number of days varies as NB into 1 by NF. Okay, combining these two equations we get this. Okay, combining these two equations we get this relation. Now let us convert it into an equation, or from these two relations we are getting this third relation. Okay, we are combining these relations. Now let us convert it into an equation. ND equal to a constant, that is K, into NB by NF. And let us say this is equation 1. This is equation 1. Okay. Now we can put these values in equation 1. So putting NF equal to, from the first condition, putting NF equal to 15, NB equal to number of bighas equal to 18, and number of days equal to 5, we get now ND equal to 5. Okay, we are putting these values in equation 1. Okay, ND equal to 5, K into NB, NB is 18 by NF, that is 15. Now let us cancel it by 3, and we are getting K equal to 25 by 6. Okay, now again putting the second condition in equation 1, putting NF equal to 10, NB equal to 12, and ND we don't know, so we are putting ND in place of ND. Okay, so putting this and this, and K equal to 25 by 6 in equation 1, we get okay, so the equation 1 was ND equal to K into NB by NF. So putting these values in equation 1, we get ND we do not know, K equal to 25 by 6, NB equal to 12, and NF equal to 10. And if we simplify this, we get the number of days equal to 5, our required answer. Now let us proceed to our next question, that is Question number 9. So it says volume of a sphere Vs, let us say volume of a sphere varies directly with the cube of its radius. Okay, the solid spheres having length okay, the solid spheres having length dash meter diameter. Okay, so r1, if the diameter of first sphere is 3/2, then the radius becomes half of 3/2, that means 3/4 meter. r2, the diameter of second sphere is 2, so the radius becomes 1 meter. And r3, third radius, if it is 5/2, then the radius will be 5/4 meter. Okay, done. These three spheres are melted and a new solid sphere is formed. Let us find the length of diameter of the new sphere. Okay, so we have to do it using variation. Okay, now let us say from this relation we can write volume of a sphere is equal to a constant k into r cube. So for first sphere, for the first solid sphere, we can write, for the first sphere we can write volume of sphere 1 equal to a constant into 3/4 cube from this relation. And for second sphere, volume of sphere 2 is k into 1 cube. Volume of third sphere is k into 5/4 cube. Okay, let us assume when we melt these three spheres and cast into one big sphere, the volume of that big sphere is V, that is equal to k into its radius cube. Now so now we have these four equations. And let us first add these three equations. Okay, so let us add 1, 2 and 3. So adding equation 1 plus 2 plus 3, we get Vs1 plus Vs2 plus Vs3 equal to k into 27/64 plus k into 125/64. Taking k as common, we can write 27/64 plus 1 plus 125/64. If we add these three numbers, we get 27 plus 64 plus 125. This is 549 plus 7, 16. 1 carry. 8 plus 2, 10 plus 1, 11. 1 carry. 216/64 into k, or k into this thing. Now if we cancel these things, we get 8 8s are 64, 8 2s are 16, 7 8s are 56. So k into 27/8. So Vs1 plus Vs2 plus Vs3 equal to this. So this is the volume of the big sphere. This is the volume of the big sphere. So we can now, we are giving it equation number 4 and equation number 5. So we can write equating the values of V from 4 and 5, we get equating the values of V, that means volume of the big sphere, equating the values of V from 4 and 5, we get k into r cube equal to k into 27/8, or we can cancel k, so it becomes r equal to 3/2 whole cube. R equal to r cube equal to 3/2 whole cube. So again we can write r equal to 3/2. So this is the radius of the big sphere. So therefore the diameter of the big sphere is 3 meter. Therefore the diameter of the big sphere is 3 meter. Let us do our next sum, that is question number 10. It says y is a sum of two variables, one of which varies directly with x and another varies inversely with x. when x equal to minus 1, y equal to 1, and x equal to 3, y equal to 5. Okay, y is a sum of two variables. Okay, one of which varies directly with x and another varies inversely with x. Okay, so when x equal to 1 minus 1, y equal to 1, when x equal to 3, y equal to 5. Let us find the relation between x and y. Okay, question number 10 says y is a sum of two variables. Let us assume these two variables are a and b. Okay, a and b are variables. Y is the sum of two variables, one of which varies directly with x. So let us say a varies directly with x and the other varies inversely with x. Okay, so we can say b varies as 1 by x. First variable varies directly with x and the second variable varies inversely with x. So from this relation we can write a equal to k1 into x, and from this relation we can write b equal to k2 into 1 by x. So if we put these values into the equation, into this equation, it becomes k1 into x plus k2 by x. So this is y. Okay, now so this is our equation. Okay, we are going to use this part, y equal to k1x plus k2 by x. We are going to use that. Now the question says when x equal to minus 1, y equal to 1. So x equal to minus 1, y equal to 1. So if we put these two values in this equation, we get, okay, if we put these values of x and y in equation 1, let us say this is equation 1. So if we put these values in equation 1, we get y, that means 1 equal to k1 into minus 1 plus k2 by minus 1. Okay, so this from this equation we are getting minus k1 minus k2 minus k1 minus k2 equal to 1, or k1 plus k2 equal to minus 1. We are just taking minus 1 as common and then multiplying both sides by minus 1. So this side becomes positive and this side becomes negative. So k1 plus k2 equal to minus 1. This is our final equation. Now again, when x equal to 3, y equal to 5, when x equal to 3, y equal to 5, and we put these values in equation 1, we get 5 equal to k1 into 3 plus k2 by 3. And if we multiply this both sides of this equation by 3, we get 15 equal to k1 into 9 plus k2. So this is our second equation. Okay, our first equation was k1 plus k2 equal to -1. So we are going to solve these two equations to get the values of k1 and k2. Okay, let us subtract equation 2 from equation 1. If we subtract equation 2 from 1, we get so the signs are changed, and this becomes positive, this is minus, this is minus. Now we can write this is 16 equal to 8k1. Okay, k2 and k2 get cancelled, so plus k2 minus k2 cancelled, so k1 equal to 2. And again from this equation we can write k1 we can write k1 plus k2 equal to -1, and if k1 is 2, then k2 should be -3. So now we have k1 equal to 2, k2 equal to -3. k1 equal to 2, k2 equal to -3. Now if we write our equation number 1, the equation was y equal to k1 into x plus k2 by x. Now the equation becomes 2x plus -3 by x. Okay, when we put the values of k1 and k2 in equation 1, we get, okay, here we can write putting the values of k1 and k2 in equation 1, we get this: y equal to 2x plus -3x. Now if we simplify it, we can write it y equal to 2x minus 3 by x. So this is our required relation. So this should be our answer.